In question 5.6, you're given a few bits of information. The first one is that the real risk-free rate is 3%. And to understand what the real rate is, you have to refer to Fisher's equation, or just this understanding that typically you're told what the nominal rate is. That's the rate of return you earn in the market. And when you back out inflation, that's the real rate. So the real rate's the nominal rate less inflation. Next, you're given that there's inflation at 3%. So this is guiding you towards what the nominal rate is. And then you're told that that inflation is over the next 2 years. It's expected 3% next 2 years. Lastly, you're told that the 2-year treasury yields 6.3%. And so then given this information, you're deducing that the remaining amount must be the maturity risk premium. That is, by foregoing cash today for receiving payment 2 years from now, you get a bit of a risk premium because money in the future is riskier than money today. So we can just simply look at the simplified version of the relationship between the nominal rate and the real rate. We could also use Fisher's, but that won't give us the solution in the textbook. So the one that's being used is this one right here. So again, we know the treasury rate's 6.3%. And we'll back out for the real rate. And then we back out for inflation. So what this is saying is this is the return, the increase in purchasing power by investing in the treasury. There's an additional amount that we get for offsetting inflation, and that difference then is the maturity risk premium. So we see that the maturity risk premium is equal to 0.3% or 30 basis points.